Okay, so let's begin. Hindi yata pwede dito yung slide presentation. So we'll stick with this. We'll stick with this form. So, so kanina sinasabi ko na yung driving force natin dito ay nonlinear. So, basically, we have a general equation for the tawag dito, yung equation of motion na general for the oscillators given by this f of x dot mx double dot plus f of x dot plus g of x is equal to h of t. Okay, maintindihan naman natin siguro kung ano itong f of x dot, yung damping component. Okay? Kasi remember, dun sa discussions natin before, yung damping force ay pwedeng proportional to the velocity. Diba? Pwedeng proportional to the velocity squared. Okay? Depende yun sa kung ano yung tawag dito, yung speed ng object. Okay? So that's why we express the second term dito sa differential equation na ito as a function in terms of the velocity, x dots. Okay? So ito yung general form na susundin natin. Okay, and x dot, f of x dot means that it can be x to the first power, x dot to the first power, x dot to the second power, and so on and so forth. Okay, yung driving force h of t, okay, nakita na natin yung before. Ang example na ginawa natin sa linear oscillations ay yung sine omega t. Okay, and ang titignan natin ngayong araw is yung nonlinear component, which is yung g of x, na kung saan yung function na g of x can be a function of, can be expressed as a series, okay, power series, x to the n. Okay. So dun sa discussion natin before, pag nonlinear oscillation or pag linear oscillation, we express the force to be equal to negative kx and yung potential to be equal to 1/2 kx squared. Okay, now, pag nonlinear na yung force, madadagdagan to ng term. So in the case na symmetric yung dito yung force, linear. Okay, in the case ng for the case ng nonlinear, yung force natin ngayon ay for example, madadagdagan ng kx plus epsilon x cubed. Okay, so madadagdagan ng term na corresponding sa x cubed. Okay, and yung potential dito ngayon is given by, sige nga, test natin kayo. Kasi ito yung mga problema nyo sa first exam. Pag-take ng derivative. Ano ang potential dito? Epsilon. Epsilon lang siya. Just a constant. I-describe natin mamaya. First term. Paano bang relationship ng f of x tsaka u of x? Paano nyo makuha ang u of x from f of x? Integrate nyo yung f of x, di ba, with respect to dx. Okay, so integrate nyo yung first term. Okay, 1/2 kx squared. And then yung second term, okay. Hindi, kasi di ba, f is equal to negative del u. Right? Kung, di ba, f is equal to negative del u. So kaya siya positive. Okay, and then yung second term, negative 1/4 epsilon x raised to the 4th power. Ayos. Meron na kayong points sa number 1. Kung exam lang to, kaso hindi. So, now, ano ginagawa ng additional term na to? Now, dito sa graph, makikita natin na tawag dito, mag-iiba yung itsura ng force at saka ng potential depende kung ano yung value ng epsilon. Okay, yung constant na epsilon. Now, yung epsilon na yan is actually a very small quantity. It's assumed na it's a very small quantity, so, but not so small to be negligible. Okay? Small such that kitang-kita mo pa rin yung effect niya. Now, if epsilon is greater than 0, ano mangyayari sa force? Madadagdagan ba o mababawasan? Remember na ang force na ito is negative kx, diba? So kung magdadagdag ka ng positive number sa isang negative number, magiging less negative siya. Right? So anong nangyari? Madadagdagan siya. Right? So tumaas yung value. Diba? Kung along the x-axis. And that's what happens here. Titignan nyo dito, okay? Halimbawa, yung negative kx, ito yon, yung dash line. Okay, itong dash line na ito, yan yung negative kx. Okay, and pag dadagdag mo yung epsilon x cube, okay, ang makikita natin ay yung solid line. Right? So pag negative yung x, okay, pag negative yung x, dadagdagan mo ng positive epsilon x cube. Okay? Positive epsilon is positive, epsilon is greater than 0. Ang mangyayari sa tawag dito sa graph is magiging ganito. Diba? So, halimbawa, this value of x, ito yung f of x, ito yung f of x na may additional, may epsilon, ito yung f of x na walang epsilon. So, naging less negative siya. Right? Right? Or naging less negative siya. Thank you. Okay? Sige, i-try nyo i-observe. So yung graph na ito, yan yung epsilon x cube niyo. Yan yung kailangan nyo idagdag para so pag positive naman yung x, okay, positive naman yung x. Halimbawa, kumuha tayo ng positive value ng x dito. Positive value ng x, then yung force ninyo ay negative, di ba magiging less negative siya. Originally, yung negative, yung value niya, magiging less negative siya kasi nadagdagan siya ng epsilon x cube. Tama? Tama? Okay. So, ganun yung nangyayari dito. Now, for the case na epsilon is greater than 0, tawag natin dito is a ang tawag natin dito sa system na ito is soft. Now, in the case na yung epsilon is less than 0, okay, ano na mangyayari? So let's take for example na yung x ay nandito. So x is positive. Ito yung positive x for linear, ito yung positive x for nonlinear. Okay? So anong nangyari? Nadagdagan, naging more negative, di ba? Kaya bumaba, nag-curve downward ito. Dito naman, pag negative yung x, ito yung negative x negative, yung force corresponding to the negative x value pag linear. Pag non-linear, naging more positive siya in this case. Okay? So yun yung nangyayari dito. And in this case, ang system na ito ay tinatawag natin na hard system. Now, in the case of potential, okay, pag titignan natin yung graph, okay, yung dash line, yan yung non-linear na force. Yan yung linear na force. Okay, yung dash line dito, yan yung linear na force, at yung dash line dito ay yung linear na force. And let's say na positive yung value ng x. If epsilon is greater than 0, okay, so positive value x, so ito yung, anong tawag dito? Ito yung linear. And then magbabawas ka ng 1/4 epsilon x to the 4th. Di ba? So ito na yung magiging value niya. So ito na yung non-linear na value. Tama? In the same way, ganun din ang mangyayari sa negative x. Kasi ito, x squared lang naman yan. Then dadagdagan mo ng negative 1/4 epsilon x to the 4th. So ito na yung bagong value ng potential dahil sa non-linear na component. And dito naman, pag epsilon is less than 0, then yung dash line will give you the linear component, and then itong corresponding sa na x sa solid line, yan yung non-linear na component. So again, epsilon is less than 0, so nadadagdagan siya. Right? So in essence, yung potential ninyo mas tumataas yung curvature. Okay, pag hard yung system. At pag soft naman yung system, medyo nagiging medyo nag-open up yung curvature. Okay? So, well, kung gusto niyo yung tandaan yan, you can do it like this, you can analyze it like this. Pero siguro kung gusto niyo yung tandaan, pag soft, di ba, pag malambot, di ba, sa pagbulaklak, di ba? Bubukas siya ng konti, and then pag medyo punong-puno ng tubig, yung bulaklak, hard yung system, so mas lalo siya nagsistick na. Okay? So para lang mas madali yung tanda. Okay. Now let's consider an example. Let's consider this example. Okay? Ito rin yung example sa book, this example 4.1. And ang nangyayari dito is meron tayong mass, okay, mass M suspended between two identical springs. Okay? Okay. Show that the system is nonlinear. Okay. Find the steady state solution for driving force F naught cosine omega. Okay. So two things, kailangan nyo ipakita na nonlinear ito. Yung pangalawa, kailangan nyo ipakita na kailangan nyo solve yung steady state na solution. Okay. So how do you show it's nonlinear? Well, you just show na yung force is proportional to x, where the power of x is greater than 1. Pag equal lang siya sa 1, yung power, then linear lang siya, right? So, kailangan nila ipakita na f is proportional to a higher power of x. Now, in this system, okay, yung dito na lang, saan ba mas maganda? I-record kasi natin, ano? So itong system na ito, andito yung mass na M. And then yung spring, it's not really stretched. It's just, it has its original length without any applied force. Okay, so yung length niya without any applied force is L. And then ganun din dito sa ganun din dito sa baba. Okay, now you might think, teka lang, di ba may gravity? O, kalimutan muna natin yung gravity. Okay, saka natin isipin yung contribution ng gravity. So let's just assume na yung spring na to is not pulled. Okay, kasi pag pinull yan, magkakaroon ka ng additional force. Right? Okay, yan. Eh, makikita natin yun mamaya. So ito yung equilibrium state niya. Okay? So walang net force dito. So now dun sa letter B, in-extend natin yung system. Okay, yung spring. Because it is extended from a length L to a length S, meron ng force na ina-apply ngayon dun sa spring. Tama? Tama? Ano yung force na ina-apply dun sa spring? Let's consider yung force along the x-axis. Kasi yung force along the y-axis is just 0. Nakikita niyo naman siguro kung bakit 0, kasi yung y component niya, yung y component acting on the mass by the spring na upward is the same as the y component acting on the mass by the spring, by the downward spring, right? So magka-cancel lang yung dalawa niya. So we consider the force along the x-axis only. So along the x-axis, ano yung force na yun? So basically, we start with F is equal to negative kx, na kung saan yung x is the elongation, right? But yan yung general na term. Pero hindi naman yan yung, in this particular case, ano yung elongation length? Ano yung elongation length? So ang original na length niya is L, and then nung hinila siya, nag-lengthen siya to a distance to a length S. So ano yung elongation length? S. Huwag kayong mahiyang magsagot dahil hindi pa naman exam to. By how much was it elongated? Sige. S minus L. Ganun lang kasimple. Di ba? Na-elongate siya by that distance. Okay? Now, of course, yung force na yan is acting along this axis, di ba? And anong tawag dito? It's the component, okay, of the force that's actually acting along this axis. So since it's a component, kailangan natin makuha yung x component. Yung angle na theta ay nandito, so it's yung component ng x is opposite the angle. So anong lalagay natin na na ano dito. Trigonometric na ano. Sine theta, right? Right? Okay. And since may contribution din dun sa baba, which is exactly the same force, kasi exactly the same yung elongation, okay? Lalagyan ko ng 2 dito. Right? And wag natin kalimutan yung negative sign. Okay? Okay. Now, also from trigonometry, we can see that S, okay, ngayon hindi na natin nakikita kasi pinagsusulatan ko. Pero ngayon nakikita na natin. So, L squared plus X squared is equal to S squared. Okay, and this might come useful mamaya-maya konti. Of course, we can also define sine theta. Okay, sine theta will be equal to opposite x over adjacent s, di ba? Tama? Okay. So, sine theta is equal to x over s, or since s is related to ln s, ln x, pwede natin isulat as L squared plus X squared. So ngayon itong force na to, we can write as minus 2k. Consider muna natin yung sine theta. So itong sine theta muna. Sine theta is x over square root ng L squared plus X squared. Okay, dahil yan sa sine theta. Ngayon yung S minus L, okay, i-replace natin yung S with this. So this will be square root ng L squared plus X squared. Okay, and minus L. Okay? Yung alin? Yes. Alam ko na pangit ang handwriting ko. Okay. L squared plus X squared. Kasi S siya, di ba? S minus L siya. Ito. S minus L and yung S na kuha dito. Okay. So, yun. Then, tawag dito, ipapasok ko yung square root, yung denominator na L squared plus X squared dun sa loob ng brackets. So, ang lalabas is F is equal to negative 2kx, and then 1 na lang ito minus L over L squared plus X squared. Okay? Multiply ko lang yung 1 over L squared plus X squared dun sa loob. At yan yung lumabas. Okay. And what do we usually do pagdating sa mga ganitong equations? Nakakita kayo ng ano? Tama, expand. Yes. Anong gagamitin natin expansion dyan? Binomial series, right? Okay. So expand natin. F is equal to negative 2kx 1 minus 1 over square root of L squared plus X squared. Ayos. Ang bilis niyong makuha. Mga veterano talaga kayo ng physics. Sa physics 1-to-1, ginawa ko yung joke na yan. Ganun lang sila. Tapos nung makuha na nila, tapos explain. Ganun sila. Okay, anyway. Shit, na-record pala lahat yan. Ano yung binomial expansion ng square root ng 1 plus x over L squared? Okay. Naintindihan nyo kung paano naging ganyan? Sorry, babalik tayo. So, yung L, no? Okay, ipapasok natin dito sa square root. Okay, so magiging 1 plus x squared over L squared squared. Okay? So maging ganyan na siya. Okay, and dyan yung i-expand natin. And importante na mayroon kang x squared over L squared dyan. Otherwise, hindi natin pwedeng gamitin yung binomial expansion. Remember, pag binomial expansion, we can only use that if x is less than L. Okay? So yun yung isang condition dyan. And then ito ngayon, ano nito? Anong expansion? Nalala nyo ba? 1 minus 1/2 x over L squared, diba? Plus 3 over 8 x over L to the 4th minus and so on and so forth. Okay? Okay. So, ngayon, ang force natin na magiging equal sa negative 2kx 1 minus 1/2 x over L squared plus 3/8 x over L to the 4th minus and so on and so forth. Siyempre, magka-cancel yung 1 dyan. Cancel itong 1 na to tsaka 1 na to. And then, ang mangyayari sa force is let's see. Yung first term is, tignan nyo, negative 2kx times times positive 1/2 x over L squared. Diba? Yung first term is, ano bang magandang kulay na gamitin? First term, this one, multiplied by this one. So negative 2 times 1/2 is 1. So negative k x over negative KL x over L cube. Okay, para lang meron tayong x over L pa rin. Okay, now yung second term will be this one. 3/8. Diba? So anong mangyayari dyan? Positive 3/4. Actually, pwede natin gawin ito. 1, di ba? Of course, magiging 1 lang siya. And, factor out natin yung KLX over L cube. Okay? So, ang matitira na x over L dyan is just 1. At ang matitira na power dyan, so ipapasok natin yung 2, magiging ano siya? 3/4, di ba? Minus 3/4. Hindi, may negative sign ka pa pala doon. So, minus 3/4 x over L to squared. Okay. Plus, and so on and so forth. Okay. Anong next step? An objective? Kailangan ipakita na nonlinear. And the way to naipakita na nonlinear siya, dapat, yes, so meron siya dapat powers of x greater than 1. And nagawa na ba natin yon? Okay, so nagawa na natin yung first na objective. Okay? Okay, so yan yung, so nagawa na natin yung first one. Okay. Of course, if x is less than L, then we can consider itong mga succeeding, we can ignore itong mga succeeding na parts. Okay, remember this part here, the second part here is not is not x over L squared. Okay? Kasi isipin, ba't mo i-ignore yung x over L squared? Eh, meron kang x over L cubed dun sa labas. It's not x over L squared, it's x over L to the 5th. Okay? Kasi kailangan mo i-multiply yung ano. Kaya pwede mo siyang i-ignore. Okay? Okay? Okay. So, ano ang next step? So now we have expressed yung tawag dito force in terms of an equation having a power of x. Okay? Ano ang next step dito? Siyempre, ang sabi dito sa problem is to find the steady state solution for a driving force F naught cosine omega t. Okay. Anong mangyayari dyan yun? So this is our driving force and may sinabi bang damping? Walang sinabing damping, di ba? So ignore natin yung damping na yon. Ignore din natin yung last term kasi walang sinasabi about it. So we can write mx double dot ay equal sa yung driving force na ito. If we ignore yung terms na yan, so minus KL x over L cubed. Yes? Plus yung driving force. F naught cosine omega. Kasi sabi rito, find the steady state solution for a driving force F naught cosine omega. Questions so far? Questions? Wala. Okay. So mx double dot, sulat ko lang ulit dito, minus is equal to minus KL x over L cubed plus F naught cosine omega. Naalala niyo ba kung paano isolve yan? Sino teacher niyo sa 1-to-1? Si Christian. Di ba sa inyo? Ako pa. Grabe. Kailan pa yun? So, anong pwede natin gawin dito? Well, what we can assume na ang isang solution is of the form x equals a cosine omega t. Okay. Pwede na natin gawin yan. Which means na mx double dot is equal to minus kl k over L squared and then a cube cosine cube omega t plus F naught cosine omega t. Okay, and to solve that, integrate lang natin yung Okay, madali lang i-integrate yan except for this cosine cube omega t. Alam niyo kung paano integrate yan? Pwede nyo gamitin yung trigonometric property para maging linear yung cosine omega. Para maging first power. Okay. So anong trigonometric property na pwede nyo gamitin? Cosine cube omega t is equal to 3/4 cosine omega t plus 1/4 cosine 3 omega t. Okay? Ngayon, linear na siya. A cube times 3/4 cosine omega t, okay, plus minus minus k over L squared 4 hindi, walang A, no? Kasi ano na siya. So 1/4 times times negative k over L squared. Hindi, may A cube din pala siya. May A cube and then cosine 3 omega. And then plus F naught cosine omega. Okay? Okay. Madali na lang integrate yan. Tama? Okay. X dot Sige, pagtulungan natin to. 3K 4 ml squared A cube over omega, right? May nakalimutan ba ako na sign? Negative dapat to, no? Okay, and then syempre pag kinuha niyo yung yung integral ng cosine omega t, negative, so mawawala yung negative sign, right? Okay, so over omega tapos sine omega t. Tama ba? Hindi pa. Hindi pa. Mamaya pa mawawala yung negative. Kasi ang derivative ng sine omega t is cosine omega t, positive. Okay, dito naman minus k over 4 ml squared a cube over omega. Okay, and then may 3 ka pa dyan. So 3 omega, so 12. Okay, tapos sine 3 omega plus f naught over omega sine omega. Tama ba? Kulang ng? Okay, m. Actually, nagpakahirap pa tayo. Pwede naman natin pagsamahin ito at saka ito. Okay lang. Practice. Okay, so, the next step, makukuha na natin yung x. Ang x ay, so, 3k 4 ml squared a cube. 3k over 4 ml squared omega squared a cube. Okay, minus fm f over m omega squared. Okay, and then ito ay cosine omega t. So, kinuha ko na yung derivative. Okay? So, yan. Tama? And then, magiging plus na to, no? Plus, ano na? Plus, k over 4l squared, sorry, k over 12 ml squared a cube omega squared na yan. Ka cube, Ka cube over 12 ml squared omega squared. And then, may 3. So ito ay magiging 36. And then, cosine 3 omega. Okay, so, yan na yung ating solution. Okay. Now, it's a bit difficult to analyze kasi ang daming mga tawag dito. Factors. Pero syempre pwede nating i-simplify yan. Remember that k is equal to omega squared. K omega squared. Yan. K over m square root is equal to omega squared, diba? Omega. So omega squared m is equal to k. So which means na itong k na to, may m omega squared tayo dito, cancel yan. Okay, and then dito, k m omega squared cancel. So pwede natin pa siya simplify further to 3a cubed over 4l squared minus f over k cosine omega t plus a cubed over 36l squared cosine 3 omega t. Okay, so well, mahirap siyang i-analyze kasi we don't know what A is, right? Of course, alam natin yung length, okay, alam natin yung force, driving force, So at some point, ginawa kong F to, but this should be F knots. Okay, and okay, alam natin yung K kasi K is just mass times omega squared, and yung omega is yung frequency ng oscillation. So, ano magiging itsura ng graph na to? So, yung lahat ng nasa brackets ay just constants. Okay, lahat ng coefficients ay just constants. Okay, mga constants lang yan. So, meron kang cosine omega t, and then idadagdag mo yun sa function na cosine 3 omega t. Okay, so yung pangalawang function has a period which is 3 times first. So, may imagine nyo kung paano magsusuperpose kayo ng cosine omega t, and then magsusuperpose kayo ng another function ng cosine 3 omega t, 3 times yung period, pero magkaiba ng amplitudes. Okay, so ganun yung magiging itsura ng x. Okay? So, yeah. Anyway, ang pinapagawa lang naman dito is steady state solution for driving force, F naught. So, kung imagine natin kung ano magiging itsura nung, well, of course, mahirap imagine na, tulad ng sinasabi ko sa inyo. Ito yung halimbawa, ito yung omega, and then yung 3 times the period, mali yata yung drawing ko. So, halimbawa, ito yung omega, cosine omega t, sorry. Tapos yung 3 times ng period niyan, so 1, 2, 3, so ganyan. Okay, so ganyan. And then pag in-add nyo yan, ano sa tingin nyo magiging itsura? Of course, magde-depend yan sa amplitude. Okay, so, let's see. Pag ganyan, something like that. And then dito mag-0. And then taas. Okay, so parang ganyan. Okay? Guess ko lang yan kasi hindi ko rin alam yung amplitude. Okay, pero if it was drawn this way, then more or less ganyan yung magiging amplitude. And how do you interpret that pagdating sa spring? Okay? And remember, yung motion dito is x. X lang, along the x-axis. So gumaganong-ganon na siya. Diba? Lumalaki yung amplitude eh. Diba? Lalaki yung amplitude ng 3 times. Yung blue, tinitignan natin. Ano? Lalaki muna siya, bababa. And then akit ulit, bababa. And then akyat, bababa, lilipat sa kabilang side. So, pag imagine nyo itong spring na to, diba? Lalaki yung amplitude niya. Okay? Babalik ng konti. Lalaki yung amplitude. Lalaki yung amplitude, babalik ng konti. Lalaki ulit. Babalik ng konti, and then konti. And then saka mag-shift sa kabilang side. Ganyan. And ganon. And then lilipat sa kabilang side. Okay? So that's how you imagine, okay, yung ganitong klaseng solution. Okay? Okay. Now, itong next na problem. Of course, really you really have to stretch yung spring. 'Di ba? Para maikabit niyo yung spring dun sa bola, kailangan niyo siyang stretch. 'Di ba? So this problem is a little bit more realistic. Wala pa rin yung gravity, pero nandoon na yung part na kung saan i-stretch niyo ng konti yung spring. Tama? And you stretch that spring by an amount D, which means na meron na siya kagad na additional na force. Okay? So ano yung additional na dito? Additional na force dito. Of course, ang additional na force F KD squared. FKD. On top of that, okay, i-swing nyo pa yung ball dun sa isang side. So ano mangyayari dito? Okay, yun yung gusto natin malaman. Ano yung X? Ano yung function na X dito ngayon? Okay, so we use the same treatment as we did before. So we start with yung force. Okay? Again, yung forces along the x-axis, along the y-axis ay 0. Net force along the x-axis along the y-axis ay 0 kasi magka-cancel lang yung upward at downward component ng upward spring at downward spring. Pero yung x component ay mag-a-add up. Right? So, syempre, lalagyan na natin dyan ng 2k, okay, and then yung displacement. Okay, by how much was the spring displaced? Ano yung total na displacement niya? Remember na yung without any force, in equilibrium, yung ang spring length is L naught. Nung na-stretch na siya, ano na yung bago niyang length? L naught plus D. Okay. Or S, di ba? Pwede rin yun, di ba? S. Okay. So, lagay lang muna natin S minus L naught. And then, of course, yung sine theta papasok. Inilagay ko lang na S minus L naught dyan para makita nyo yung similarity dun sa first na problem. Okay, kasi sa first problem, it's S minus L. Pero ngayon, it's S minus L naught. And by writing this, we say na it's stretched by S minus L naught amounts. Okay. Or by L naught, by D plus, actually hindi natin alam. Okay. Kasi D, kasi hindi natin alam kung gaano siya stretch din. Diba? Pero alam natin na originally it's L naught, pero yung fully stretched siya, it's S. Right? So yung tawag dito, yung stretching length niya is S minus L. Okay. And then, of course, from trigonometry, we just write S squared is equal to X squared, okay, plus L squared. Okay. Just the second figure, L is L naught plus D. Okay. And then yung sine theta, of course, yung ginawa din natin kanina, sine theta is equal to ano to? X over L squared plus X squared square root. So yung force natin ngayon is, so ano yung force? So negative 2k, and then treat muna natin yung sine theta. Sine theta is X over X squared square root times, S is X squared plus square root minus L naught. Okay. Ganyan na ganyan yung ginagawa natin kanina. Okay. Siyempre, gusto natin bawasan yung variable. So, we replace L naught by L and D. So, minus 2kx over L squared plus X squared. Tapos, square root ng L squared plus X squared. And then, papalitan ko yung L naught ng L minus. It's easier to replace L naught with L. Okay, so that your force is in terms of L. Kesa i-replace nyo yung L naught with yung L with L naught. Kasi dalawa yung papalitan dyan. Hindi ito at saka ito. Okay. Okay. Okay, so anong ginawa natin? Anong next step dito? Nalala nyo ba dun sa solution? Hindi muna. Dinistribute muna natin yung yes. Yes. So, dinistribute muna natin siya. So minus 2kx tapos ano na siya? 1 minus L over D square root ng L squared plus X squared. Okay? And then saka natin kinuha yung binomial expansion ng 1 over square root ng L squared plus X squared. Okay, dito na magde-deviate yung solution from yung previous na solution na ginawa natin. So by applying the binomial expansion, we have 1 minus L minus D, tapos yung binomial expansion. So 1 minus, ano yung binomial expansion nito? 1/2. Ay, sorry. Kailangan natin ibaba yung L. So, bago muna yon. Yes, exactly. It's L squared. So F is equal to minus 2kx, 1 minus L minus D over L, 1 over square root ng 1 plus x over L squared. Kaya lang, naintindihan nyo kung ba't nagkaroon ng L dyan? Okay, kasi pinactor out lang natin yung sa square root. Then, saka natin i-apply yung binomial expansion. 1 minus L over D over L times 1 minus 1/2 x over L squared plus 3/8 x over L to the fourth minus so on and so forth. Nangyari. The record pa rin ba? You are sharing screen. Storbo yung tao na yun ah. So ito, tsaka ito. So, of course, gawin natin is i-distribute natin, no? Distribute natin ito dyan. Doon. Okay. Then ignore na natin yung x over L. X over L na to. So, F. So, ang sinasabi ko is from here, ignore na natin. Kasi x is less than. So, ang meron tayo is negative 2kx 1 minus L minus D over L. Okay lang? My plus 1/2 x over L squared. Hindi na, ignore na natin siya. Okay. So, hindi, tama. Wait, ano nangyari dito? So, pwede kong i-actually isulat ito. Dito magic ah. Ano lang to? 1 minus D over L. Okay lang? Naintindihan nyo paano nangyari yan? Okay lang? Kasi pag sinulat ko yan in that way, magka-cancel lang yung 1 na to tsaka yung 1. Okay? So yung first term natin will be negative 2kx and then may negative, may negative sign ka dyan, negative sign, so negative pa rin siya. D over L. Yan yung first term. Then yung second term ay ko lang. D over Lx. Then yung second term ay minus K. And then yung L over D over L, gagawin na ulit natin 1 minus D over L. Or not. So ilang L na yon? So L minus D over L cube. Diba? And then X cube. Okay? Pag dinisibit mo. Now, anong naging difference nito dun sa previous na solution? Ready. Yes. May additional ka na linear term. So kanina wala yung linear term. Right? Pero because we stretch the spring para maabot niya yung mass, nagkaroon ka ng additional na linear term. So now we have a linear term and a non-linear term. And we can do the same and solve for x, okay? By applying so mx double dot is equal to minus 2k d over lx minus kl minus d over l cube x cube, then plus f naught cosine omega naught, omega t. Okay. So we can do exactly the same thing as we did before and solve for x. And again, we can assume that x is equal to some function a cosine omega t. Okay, so we have x double dot is equal to minus 2k d over ml x. Sorry, a cosine omega t. Okay, ganito na yung gagawin ko. Plus f naught cosine omega t. So lahat ng cosine omega t, ginroup ko na. Minus k l minus d over m l cube x cube. Oh, x cube. A cube cosine cube omega. Okay? Okay. Now, at this point, hindi ko na i-detail yung solution kasi alam niyo na kung paano solve. I'm sure pagpa-practicean niyo to. I'm sure pagpa-practicean niyo to. Tama? Tama? Okay. Ganon kataas ang confidence ko sa inyo, di ba? Ha? Kaya kayo walang confidence sa sarili kasi hindi kayo nagpa-practice. Practice kayo. So ilalagay ko na lang dito yung final na solution. It's actually in the book. So detailed naman yung step dun sa book. Okay, and we have this alin? A cube, yes. A cube. Small a, kasi yung a dito, nag-ano siya a is equal to 2k d over ml. Okay. Yung epsilon, yung epsilon over m, ginawa niyang epsilon na lang. Okay. And then yung g is equal to f naught over m. Okay, so yan yung mga ginawa niyang replacements. Again, andiyan yan sa book. So para makita niyo lang yung step by step. Now, ano ang similarity dito? Similarity is that again, meron kang cosine omega t na function and then meron kang cosine 3 omega t na function. Okay, and of course, yung mga nasa parentheses ay constants. Okay, or yung coefficients ay constants. Now, the big difference here compared to the previous one, okay, balikan natin yung previous one. Nasaan na yun? Solution yun. Okay, sige, tignan natin kung ano, ma-analyze yun na mabuti. Ito yung previous na solution ng x. Okay? Okay. Okay na? Huwag kayong masyado mag-focus sa detail. Okay, huwag kayong masyado mag-focus dun sa dun sa parenthesis coefficients. Okay? Tignan natin ngayon yung solution dito. Ha? Hindi, it's not the sign. The epsilon is just a constant. So it's hindi rin yun. Yes, meron kang 1 over omega squared. Tignan nyo. Ito, walang 1 over omega squared. So ang dali nating makukuha yung behavior kasi graph lang natin yung cosine omega, graph natin yung cosine 3 omega t, tapos superimpose. Pero dito, yung first term ay merong 1 over omega squared. So it's not straightforward na i-add lang natin yung cosine omega t tsaka yung cosine 3 omega t. Right? Kasi meron kang omega squared doon. And that will affect yung frequency ng oscillation. Okay, so this type of behavior will lead to what's called a hysteretic behavior, okay, which we will discuss after a couple of meetings. Okay? Pag hysteresis, ibig sabihin lang na para siyang bumabalik. Okay, nagsa-cycle siya, bumabalik. Okay, anyway. So, more points to analyze. Halimbawa, so nakuha natin itong force na to. Saan na ba yung force na sinolve natin? Ito yung force na sinolve natin kanina, no? For yun dun sa original, dun sa unang-una. Yan yung force. Okay? And then yung force na sinolve natin dun sa pangalawa has this form. Okay? So, itong force na to, would you call this force being applied to a hard or a soft system? So ang kailangan nyo is di ba, epsilon. Di ba? And remember originally yung minus kx squared plus epsilon x cubed. Okay. So ano yung epsilon dito sa naka-box na yun? Yes, kasama yung negative. Okay. So yung L ba ay mas malaki sa D? Base dun sa figure. Sorry. Ano ba yung figure na tinitid? Ayan. Yung L ba, yung capital L ba mas malaki sa D? Yes, di ba? So, kung babalikan natin yan, yung epsilon nyo ba is greater than 0 or less than 0? Yes. So, less than 0. So, anong klaseng system to? Yes. The system that's being described here is a hard system, as well as the problem. Okay. Okay. Now, try to recall kung ano yung ginawa natin sa linear systems. After describing, what other methods did we use para i-describe yung linear systems? Yung behavior ng linear systems. Kung hindi nyo ma-recall, pwede nyo i-flip yung notes nyo back to the previous. Ano pa yung other means to describe the behavior of a system? Hindi. What about momentum? Okay lang. Ano? Any guess? Ko? Any guess? Tinding editing gagawin ko dito sa video na to kasi may post tayo ng mga 1 minute dahil nagtatanong lang ako. Yes, phase diagram. Okay, one other way to describe how our system behaves is through a phase diagram. Ano ulit ang phase diagram? Graph siya ng velocity versus position. X dot versus X. Okay? By doing that, we're actually essentially graphing yung kinetic energy versus potential energy. Kasi kinetic energy is in terms of velocity. Diba? And yung potential energy is in terms of position. Okay? So that's why significant maintindihan ninyo na kung ano yung ibig sabihin ng phase diagram. Kasi it's not just about velocity versus position, but it's also about energies. Okay? And how energy is conserved. Okay, so again, this system is tawag dito, a soft system. A soft and a hard system. Okay, pero yung system na to describes an asymmetric force. Okay, paano siya naging asymmetric? Kasi kung titignan nyo, along the positive x-axis, the system is actually hard, pero along the negative x-axis, the system is soft. Okay? And that's because yung potential is asymmetric. Tignan nyo yung potential. Okay, so dun sa positive x-axis, medyo inward yung potential, so that corresponds to a hard tawag dito system. Pero dun sa negative x-axis, yung potential is soft. Okay, medyo outward medyo bumuka ng konti yung potential. So the system is soft. So that's what happens if you have a force that is asymmetric. Okay? Now, how do we describe yung phase diagram ng system na yan? Okay, so we describe the phase diagram through this. So sa taas, andyan yung potential. Okay, nakikitang-kita naman na asymmetric siya, and we choose certain energies. Okay, let's say energy E1 na medyo mataas. Okay? So anong nangyayari sa kanya? Okay. Tignan muna natin dun sa dito. Halimbawa dito siya nag-start. Diyan siya nag-start. So anong mangyayari dito? Siyempre bababa siya papunta sa equilibrium position. Okay, and then dahil may velocity siya, akyat pa siya. Okay, and then aabot siya dito, and then bababa siya dito. Okay. Now, may difference yung velocity dito, okay, at yung velocity dito. Right? Dahil lang asymmetric yung system. Okay, dito, okay, mabagal yung change in velocity. Ay, nakikita niyo ba? Sorry. Mabagal yung change in velocity. Dito, mabilis yung change in velocity as a function of position. So to describe that dun sa phase diagram, remember the phase diagram is velocity versus position. So from here to here, okay, alam natin na dito maximum yung energy niya, that's E1 at the maximum position x. Okay, and then ito yung equilibrium position at x equals 0. Okay, and maximum naman yung kinetic energy diyan. Okay, maximum kinetic energy and potential is 0. So mangyayari is habang nagmo-move yung particle towards the equilibrium position, nag-i-increase yung kanyang kinetic energy. Itong difference na ito, nag-i-increase. Okay? So kaya nakikita natin yung difference na yan dito. Okay? And then pag lumagpas na siya dun sa equilibrium position, dun sa x greater than 0, yung energy na yan ay nababawasan. So nakikita natin na yung energy na ito ay nababawasan. Of course, I'm talking about kinetic energy. Right? And since I'm talking about kinetic energy, I'm also talking about velocity. Right? Okay, kasi di ba, kinetic energy is just 1/2 mx dot squared. Okay? So, then pagpabalik, ibabalik na siya dito. Okay, papunta dyan. Ano lang nangyayari sa energy niya? Yung energy niya ay dito na. Yung velocity niya kasi is negative, di ba? Pointing towards the negative x-axis. Yung energy niya is still the same, pero yung velocity is pointing towards the negative axis, so kaya siya nasa baba. Okay, hanggang sa umabot siya sa equilibrium position. Okay, and then at the equilibrium position, ano tawag dito, maximum yung energy niya. And then, magdi-decrease na yung velocity niya, pero same pa rin yung direction, kaya negative pa rin yung velocity hanggang sumabot siya sa maximum position. Okay? Ganun din dito. Okay? That's what happens to when the energy is E1. And the same, pag energy E2 naman, mas maliit lang of course yung magnitude. Okay na? Anong oras kayo nagsistart ng klase niyo sa Tuesdays?
8:30.
Wala akong right na mag-complain. Kasi ang first class ko, 6. Kayo. Pag PTH. Ano? Okay. Kanina, tinitignan natin is potential which is which has stable equilibrium. Ito naman ay potential which has unstable equilibrium. Right? Okay. So paano naman natin i-describe yung phase diagram ito? Okay, let's start with E1. E1 nandito. Okay? Let's say na nag-start yung particle somewhere here. Okay, at that position, yung velocity niya is positive. Okay. Yung velocity niya is positive. Okay? Paano ko alam na positive? Well, pwede rin naman pababa. Ha? Paano ko alam na aakyat siya? Yun muna ang tanong. Remember, ang pinag-aaralan natin dito yung E1. Okay. So how much energy does the particle have in this case? How much kinetic energy? Pag i-graph, just basing on the graph. Walang quantification. Sa graph lang. Hindi. Hindi siya approaches E0. Tignan nyo kung paano ko dinescribe yung energy dito kanina. Dito sa phase diagram, dito sa baba. Or dito sa taas pala, sorry. How much excess energy does the particle have dito? Pag andito yung particle, okay, wala siyang excess energy. Pag andito yung particle, ang energy niya is E1 minus this one. Okay, kaya yung velocity niya has this amount. Okay? Pag nandito na yung particle, yung energy niya is E1 minus U. Ano bang E1 minus U? It's the kinetic energy, di ba? Yun yung remaining niyang kinetic energy. E1 is the total energy. Right? Di ba? Di ba sa 101, di ba? Okay, balikan natin yung 101 ninyo ha. Potential energy, di ba? Ito yung energy, yan yung total energy. Yan yung E plus E equals T plus U. Ito, yan yung potential energy. At ito, yan yung kinetic energy. Diba? This one, hanggang dito, yan yung kinetic energy. And mula dito hanggang dito, yan yung potential energy. At ano yung sum? Yung E. So kung may energy siya na E1, ito, yan yung potential energy. At ito, yun yung kinetic energy. And yung kinetic energy is translated as velocity pagdating sa phase diagram. And it has this much velocity. Right? Tama? Diba? Dahil lang dyan. Okay, and the velocity is positive. Kasi may excess energy siya. Okay? Gagamitin niya yung, di ba? Nag-i-increase, di ba? From here to there, nag-i-increase yung kanyang velocity. It's moving towards the equilibrium position. Kaya positive yung velocity. Okay? Okay. Let's see kung naintindihan niyo yun. Again, E1 yung tinitignan natin. So, from here. Okay. Typically kasi nandito tayo, no? Okay, yan yung ating U is equal to 0, right? Typically yan yung U equals 0. Pero siguro kung nilagay ko yan dyan, baka maging confusing sa inyo. Okay, so ilagay ko na lang muna dito pansamantala. Okay? Okay. So, this means na if this is E1, asan yung U? Ito yung U. Right? Ito U. Yung matitira ay, at ang matitira is E1 minus U. Right? So, this one is kinetic energy. And that translates to velocity. Okay? Now, anong gagawin natin? Anong mangyayari dyan sa kinetic energy na yan? Anong gagawin ng kinetic energy na yan? Pwede niya i-push paakyat, di ba? Kasi it has sufficient energy para i-push niya paakyat. And kung ipupush niya paakyat, anong mangyayari? Anong sign ng velocity? Positive. Okay, kaya dito, positive yung velocity. Diba? Diyan positive yung velocity. And negative yung displacement kasi nandito yung x. Okay? So pag aakyat siya, pupunta siya sa equilibrium position, dito na siya aabot. Okay, pagdating sa equilibrium position. So, bakit siya nandito at bakit wala dun sa 0? Bakit nandito yung energy E1? Exactly. Kasi meron pang excess na energy na natitira. Di ba? Meron pa siyang excess energy. Okay, now, wala na siyang ibang pwedeng puntahan. Kasi siyempre susundan niya lang yung behavior niya will just depend on the potential energy. Di ba? So, and that position is an unstable equilibrium position. So, anong mangyayari sa kanya? Bababa na siya. And yung energy niya ulit ay mag-i-increase. So, yung energy niya ay mag-i-increase. Okay, kaya dito, yung phase diagram ninyo, pa ganyan. Right? Right? Dahil na-appreciate nyo, yung mga bibig nyo, gawin yung parang yan, ganyan. Parang yung phase diagram. Yes. Sorry. Okay. Now, tulad ng sinabi ko sa inyo, it can go either way. Pataas or pababa. Tama naman kayo, pwede siyang bumaba. Wala namang pipigil sa kanyang bumaba. In fact, pag bumaba siya, ang behavior niya is negative yung velocity. Di ba? Yes. Yung portion ng phase diagram na yun ay nandito na sa baba. Pag ang velocity niya is negative, hindi na siya akyat. Baba siya dire-diretso. Tignan niyo kung saan nakaturo yung arrow. Diba? Kung dito yung starting point niya, di ba? Pababa na siyang diretsyon gano'n. Right? Right? Okay. So it can go either way. Kaya dalawa yung phase diagram pag yung E1 yung dinidescribe natin na energy. Kung E0, ganun din. So kung E0, of course, wala na siyang excess energy. Dito. Yan yung E0. Wala na siyang excess energy pagdating sa equilibrium position. Okay, kung dito siya nag-start at paakyat siya, it has a positive velocity. Okay, and then didiretso siya sa equilibrium position. And then since unstable equilibrium yan, mag-increase ulit yung energy niya. Pero pwede rin siyang bumaba, di ba? Okay. Kung bababa naman siya, nandito na yung position niya, hindi na siya akyat, o hindi na akyat yung dot dun sa phase diagram, bababa na siya dire-diretso. The velocity will become more negative and it will move towards a more negative position. Okay? Okay. Now, what about E2? Anong magandang kulay? Shit, dami pagpipilian. Yung glitters. O yan, glitters. Okay. Okay. So, asan ang E2 dito? Yes. So let's say na dito naman tayo sa positive x-axis. Nakaka-distract. Nakaka-distract. Okay, so halimbawa nandiyan yung E2. Pwede ba siyang umakyat or pwede siyang bumaba? Pwede ba siyang umakyat? Yes, it doesn't have sufficient energy. 'Di ba? Nasa baba siya nung inat, 'di ba? So the only way there's no other way for E2 to go but bababa lang siya. Okay? So towards more positive. Okay, and anong tawag dito? Increasing kinetic energy. Diba? So, increasing velocity. Ginusto nyo yan. Okay, and then makikita nyo na, di ba, ganyan lang yung kanyang nakaka-distract talaga. And pag nandito siya, bababa lang din siya towards more negative x, okay, and more negative velocity. Okay? So, ayos? Okay. Yes?
So dun sa right, sir, ba't pataas yung arrow, sir?
Ano?
Dun sa...
Okay. Oo nga. Yes, so ganito yun. Kasi nag-start ako from E2 kagad eh. Halimbawa, nandito yung dyan siya. Pwede ko bang palitan? Earth. At least darker. O, nandiyan siya. Ano mangyayari sa kanya? Bababa siya. Diba? So, towards... Okay, meron siyang potential energy. Then meron din siyang... Ito yung kanyang kinetic energy. Okay, so nasan yun din sa phase diagram? So actually, nandito yun sa phase diagram. Asan ba yun? So ito yung E2. So itong point na to corresponds to this one. Okay, kung saan equal sa E2. And itong point na to, it is... hindi pala siya pwedeng umabot doon, ano? Oo, hindi siya pwedeng umabot doon, sorry. Okay, hindi siya pwedeng lumagpas ng E2. Okay, hindi siya pwedeng lumagpas dyan. So, halimbawa, dito siya nag-start. Pag dyan siya nag-start, pwede pa ba siyang umakyat? Does it have enough energy? Ang reference natin dito, storbo yan. Okay, may energy pa siyang konti, di ba? And then ito yung potential, right? So, may konti siyang energy. Enough ba yun para umakyat? According to the phase diagram? Hanggang E2 lang. Okay, akyat siya hanggang E2 and then bababa na dire-diretso. Towards more positive x-axis and increasing velocity. Dito increasing velocity din ito, increasing speed yan, pero decreasing velocity kasi negative yung sign. Okay. So I hope na naintindihan niyo 'yon. Next meeting will start with this one. So this is the phase diagram of what's called the van der Pol system. And so yun yung simulan natin. Any questions?